So hello everyone. In the last session we have discussed about the grouping of cells, and we have also discussed about the series combination, parallel combination of cells, and then we have seen the maximum power transfer theorem. We have discussed the electric power, a lot of things we have seen. Now in this session we are going to talk about the electrical instrument. Basically this is going to be I think it is going to be the last lecture. We have to discuss about the two types of electrical instrument in our syllabus. So first we will start with the galvanometer. First we will start with a galvanometer. Basically, what is a galvanometer? Galvanometer. First thing is that, first my question is that what is a galvanometer basically? What is the use of it? Why we use galvanometer? What is used to perform? Like this is my question. Okay, means what is a galvanometer basically? What is galvanometer? If you see, the galvanometer is nothing, it is a device. First thing, it is a device, or you can say electrical instrument. Okay, it is an electrical instrument. Electrical instrument. It is an electrical instrument. Then what is the work of this electrical instrument? What is the use of it? We basically use to measure the small current and small voltage. Okay, the use is to measure the small current and voltage. Means if there is any small current and voltage variation, it is used to measure that value. That is going to be measured by using the galvanometer, correct? Galvanometer will use to measure this. Basically, if you see the galvanometer, in galvanometer we have a something like this. Okay, it is something like this where there will be two knobs will be there. This is suppose positive, this is negative, and there on this screen, if you will see, you will have a one dial like this, and there are the small arrows will be there like this. So it will rotate either in this direction or in this direction. That is basically a galvanometer diagrams look like. But in this session, what is our aim is basically that what basically galvanometer do. Galvanometer used to measure the current and the voltage, but the problem is that we can measure only the small. The thing is that we can sorry, we can measure very small sorry current and voltage. Means the measurement we can do is a very small. It's not like you can't measure the current in ampere. Generally we used to measure the current in milliampere or microampere by using the galvanometer. That is a problem. We cannot measure the bigger values, otherwise the galvanometer will burn. If you try to measure the bigger values, if we try to measure bigger value, it will burn. It will burn. Basically what we have to discuss here in this chapter, we have to discuss the conversion of galvanometer to, first is ammeter and second is voltmeter. Okay, why we have invented ammeter? So that we can measure the value of current, large value of current in ammeter, and similarly we can also measure the value of voltage, large value of voltage by using voltmeter. Okay, but the working we will discuss in magnetism. Working we will discuss in magnetism. Okay, that discussion will be done in magnetism. In magnetism we will understand how its working take place. There we will understand the working of the galvanometer. Clear? So let us start our approach basically. I hope you understand this thing. This is a basic idea. So first we have to understand about ammeter. Okay. So let us start with ammeter. What an ammeter is? Basically, what is an ammeter? If I ask you, what is an ammeter? See, ammeter, first you tell me, like, what is the use of ammeter? It measures current. Simple. It measures current in a branch. That is the first thing. Or better to write like this. In spite of writing like this, it is better to write like this. It measure current. Simple. It measure current. Wherever you will connect, it will measure the current. Now the question is that how to connect? How to connect? How to connect? So it is connected in series. In series. For example, let's take one example and try to understand the thing. Suppose we have a sorry, excuse me, what is the problem? Suppose we have a battery of 10 volt, correct? And suppose there is a resistance of 5 ohm is there. Then can you tell me what will be the current in this branch? The current will be obviously 2 ampere, correct? That will be the current. Now I want to measure this current. Okay, I want to measure this because suppose I give you one battery of 10 volt and I give you the some resistance value, okay, and I ask you to tell me the current. So how will you tell? If you don't know the resistance value. Suppose you don't know the resistance value and you have just connected a battery across the resistor and I ask you to calculate the current. How will you calculate the current? For this you need an ammeter, obviously. So what we will do, because if you know the resistance value, you can directly divide and calculate the current. But now for measuring the current, what I did, I just put some ammeter. Now how the ammeter should be connected in series? So let me connect one ammeter. This is a symbol of ammeter. Okay, I connected an ammeter with a battery of same 10 volt and this is 5 ohm, and obviously the ammeter has also some resistance. So let the resistance, let resistance of ammeter is equal to, let us take 1 ohm. Okay, generally it is very small, so we will take, and there is a reason why it is small. Let us consider it is 1 ohm. No. So what will be the current now? If I ask you what is the current now, because this is the current which is measured. So what is the current measured now? So current measured is how much? 10 divided by 5 plus 1, because the resistance of this is 1 ohm and they are series. So what is the value you will get? You will get, that is 5 by 3, that is nothing but how much? 1.6 ampere. Now you can see my original current is 2 ampere. This ammeter should have to measure the current of 2 ampere now. But how much current it is measuring? It's measuring only 1.6 ampere. So it is measuring the current less than the original value. So that is a not good ammeter or bad ammeter? It is a bad ammeter. So if I want to make a good ammeter for a good ammeter, what should be the condition? Good ammeter, what should be the condition? Or you can say ideal ammeter or ideal ammeter. Sorry. What should be the condition? The resistance of ammeter should be almost equal to 0. That is a condition. The resistance of ammeter should be almost equal to 0. Then in this case only, we can say our ammeter is a good ammeter. That is a condition. That is a condition for a good ammeter, correct? So that is a condition for a good ammeter. Then only we can say it as a good ammeter. So how we make a ammeter? Now the question arises, how to make a ammeter? How to make a ammeter? Question is that how to make a ammeter? See, we convert the galvanometer to ammeter by connecting a shunt resistance, or you can better just you can say it as a shunt, that is also okay. Shunt. Now the question is that what is shunt? Shunt means the resistance connected in parallel. Okay, so how it basically it's look like, if we see the diagram, suppose this is my galvanometer G, and suppose the resistance, let G means galvanometer has resistance, this value I am assuming, okay, they will be given to you, that is Rg, and current in galvanometer, let us take current in galvanometer is suppose Ig. Okay, so how to make a ammeter? Basically we are going to connect a one resistance in parallel with the galvanometer, that is called as shunt, suppose whose value is S. Okay, and this is complete, this complete known as a this complete thing which you have got by connecting all this thing this complete thing is known as a ammeter. This whole thing is known as a ammeter, correct? This whole thing is known as a ammeter. So suppose current I is coming and I want to measure this current I. So what will happen? There will be small current Ig will go here, and here the current will go I minus Ig, correct? I want to measure this I. Now what is one thing is that the voltage drop across this is equal to the voltage drop across this. What is the voltage drop across this? That is S into I minus Ig is equal to Ig into Rg, correct? Resistance of galvanometer is Rg. Now from here, can I calculate my I value? Yes. What is my I value? What is my I value? I value will be, see, this will be divided here, this value S will be divided here, and Ig will come here. So you will get Ig into 1 plus Ig into 1 plus Rg by S. So in this equation, apply the condition, apply this condition, you apply this condition in this equation. If you apply this condition, if you tend x is tends to, means S is approach to 0. If S is approach to 0, this value will become how much? Infinity, correct or not? If S will, because I am making this as small as possible, if this is becoming more smaller and smaller, what is going to be happen? you can see as S is going to, or you can just bring it to denominator. What I did, I just bring this to a denominator, okay, and I just bring Ig that side, then I have taken Ig common, so it will become Rg upon S plus 1, correct, Rg upon S plus 1, that is I value. So if my S is approach to, first you note it down up to here, first my you note it down up to here, then I will write it. Okay, now this is a condition there, but basically one more thing before writing that condition, one more thing is here, this S value we will keep very much less than Rg. If this is the thing, you tell me, if this is the thing, if my S value is very less than Rg, this value will approximately approach to 0, correct? So my I will be in this case, my I will be almost equal to what? Ig, and that is what we want to measure. Clear? My I value will be approximately equal to Ig, and that is what we want to measure. Simple. And suppose if my S is equal to 0, what is my all the current? If my S will all become 0, all current will go from this path only. Okay, there will be no current in this path. All current will go in this path, and we can measure the current. So that is how we used to, basically here we are getting two things. See, we are able to protect our galvanometer also, because the resistance of this is less than the Rg. If it is like this, then most of the part of the current will go in this branch, correct, and only few amount of current will go into this branch. And if this condition is fulfilled, then my I is approximately equal to Ig. That is what it is saying. So whatever the Ig we will measure, that will be the same equal to I only. That is the condition. So we are basically doing some adjustment into the configuration, and we are getting this value. So sometime in the paper they ask you to calculate S value. They will give you I, Ig, R, everything will be given. They will directly ask you to calculate S. So that is called as a shunt resistance. If I ask you what is the resistance of the ammeter, R net of ammeter, can you tell me? Yeah, they both are in parallel combination. So what is the value? It will be Rg into S divided by Rg plus S. That is the total resistance of a ammeter. I hope it is clear that how to make a ammeter. Because see, if here in this equation, if you make S is equal to 0, obviously Rg will also tends to 0, because S is less than Rg, na? Sorry, Rg, 1 minute, I did some mistake. S is, sorry, correct only, S is less than Rg, correct? Did some mistake or it is correct? Oh, sorry, 1 minute. S is, okay, S is less than Rg. That means I minus Ig will be very much greater than Ig. Now it is correct. Okay. Yeah, now it is correct. Yeah, sorry. What I am telling here, if my S is tends to 0, suppose my S is 0. Okay. Suppose my S is 0. Means what I am saying, my S is tends to 0. Then what will be the happen? You can see from here also. If my S is approach to 0, all current will go into this branch, correct? All current will go into this branch. So automatically my Ig will become what? 0. Automatically my Ig will become 0. So I can say if my S is 0, and you can put it here also, if S is 0, S tends to 0, this quantity will tends to infinity, and I value is approximately equal to infinity. Means infinity means nothing but it is all the current will go into this branch. All the current will go into this branch, and it will protect our galvanometer from burning, because in galvanometer we can maximum current we can flow is the Ig. Beyond Ig it cannot have a higher current than Ig. So that is a condition. So generally what type of questions came into the exam, they will give you everything and they will ask you to calculate the shunt value or either the galvanometer resistance, like that. It's very simple. Just you remember this and you apply this, you can calculate. Okay, clear? Important is, now the next very important part is the conversion of galvanometer to voltmeter. What is voltmeter first? Sorry, voltmeter. What is voltmeter? Okay, what is voltmeter? What do you mean by voltmeter? First of all, you try to tell me, what do you mean by voltmeter? What do you mean by voltmeter? What is the work of a voltmeter basically? See, voltmeter is basically used to voltmeter is used to measure the potential difference across two terminals. Okay, that is mean by the galvanometer. So let us and how to connect basically galvanometer, how we are going to connect, we used to connect it in parallel. The connection is made in parallel. So let us take one example and try to understand the things better in better way. Suppose I have a same question, 10 volt of power supply is there, 5 ohm resistor is there suppose, okay, and I ask you what is the voltage across this. You will say, sir, the voltage is 10 volt. But if I want to measure this voltage, I put a one galvanometer in parallel, correct? Because how it has to be connected, it has to be connected in parallel. So suppose I have connected a galvanometer, correct? And this is 5 ohm, and I connected a one voltmeter, voltmeter like this. And suppose this voltmeter has some resistance of 10 ohm, okay, some resistance of 10 ohm. Now what is the voltage? So if you want to measure this voltage, let us do the calculation and try to measure the voltage, because basically what galvanometer will do, galvanometer will try to measure the voltage across this thing, correct? But we can let me do slide change. In this example the change will be not visible. We can do one more thing, because this example will be not appropriate for this. We can do one more thing, wait, yeah, sorry. So we can take suppose 5 ohm, let's take one example now, then it will be more clear. That is also 5 ohm. So then here the voltage will be 5 volt and here the voltage will be 5 volt. But suppose I want to measure the voltage across this. So what I did, I simply taken the same circuit, and I don't know the resistance value, that's why I am putting the voltmeter. Suppose this is 5 ohm, and I have connected a voltmeter to measure the voltage across this, and it has a resistance of 10 ohm. This is given, okay, and this is 10 volt. Now tell me what is the voltage across this. Now if you will calculate the voltage across this, what is the value you will get? What is the value you will get? That is my question. If you calculate the voltage, this voltage V, this voltage will be nothing but 10 by 3 into 10 divided by 10 by 3 plus 5. So if you do this calculation, it will be 100 by 35, correct? Not 35, I think so. Oh, sorry, not 35. It's 10 will be cancelled out, 15. So 15 plus 10 is how much? 25, correct? So this value will become 15 plus 10 is 25. So this value will become how much? 4 volt. So you are getting the voltage across this. How much is the voltage you are getting here? You are getting 4 volt here and 6 volt here, correct? So the total voltage. But what is the value we have to get? We have to get 5 volt. But here we are getting 4 volt. So what So is this a good galvanometer? The answer is no. Answer is no, sir, because we want it has to measure 5 volt, but it is measuring 4 volt. So this is not a good galvanometer. So for a good galvanometer, for a good, or you can say for an ideal galvanometer, okay. So for 1 minute. For a ideal galvanometer, or sorry, not galvanometer, voltmeter, what is the condition should be there? The resistance of voltmeter, okay, that should be equal to, or it should be tends to infinity. Okay, that is a condition, means it has to be very much high, so that no current will go across this. If there will be no current in this branch, there will be no voltage drop across this, so it will directly measure the voltage of this. Are you getting my point? So that is a difference. So what we are going to do, so for conversion, so for making a voltmeter, sorry, voltmeter, we are going to connect, suppose this is my galvanometer, we are going to connect a resistance R in series with galvanometer. So this is Rg, and this connection will give you, okay, this connection is nothing but a voltmeter. This is act as a voltmeter, correct? So what is the current in this? It will be Ig. So what is the voltage we will get? The voltage, if you want to write, it will be something called Ig into Rg plus R. That is a relation valid here. And if I ask you what is the net resistance of voltmeter, that will be nothing but Rg plus capital R. And for ideal condition, if you put my R is equal to infinity, then what is my condition? My Ig will become 0. And if my Ig will become 0, what is the voltage drop? Don't, like, the voltage drop across this will 0. So whatever the voltage will be present in the parallel component, in that voltage will be visible to you. Clear? So that is a case for an ideal conversion of a voltmeter to a galvanometer and a galvanometer to a voltmeter. How to do this conversion? I hope you are clear. Okay. Now there is something called as a percentage error. Percentage error in ammeter. Basically, percentage error is nothing but how much error you are getting. Suppose I have a circuit, okay, I have a circuit and I have measured the current without the ammeter. Suppose I have some circuit, suppose the voltage is V and suppose some resistance is there and some current is there, I. This current I is nothing but I ideal. This is my I is equal to I ideal, correct? This is I ideal. Now what I did, I connected a ammeter to it, and then it's measure some current I measured. This here it is called as a I measured, correct? So what is my percentage error? The percentage error will be obviously I ideal minus I measured, how much current has been measured, divided by I ideal into 100. Now you tell me what is my I ideal. Similarly, you can do for the voltmeter also. What is my I ideal? My I ideal will be, that is V upon R, minus what is I measured? I measured will be, suppose this is my R and this is some RG, sorry, R ammeter, and R ammeter we know. What is R ammeter? R ammeter is defined as RG into S upon S plus RG. So just put these values here, you will get V upon R plus RA divided by V upon R into 100. So when you calculate these values, you just take the V common and just do the division. What you will get, see, V will be cancelled out and we are getting 1 minus 1 upon RA plus RB. So basically it will become RA upon R plus RA into 100. That is a percentage value we will have. Now if you want, you can put the RA value here, you will get the exact value. So that is how we can measure the percentage error in a ammeter. Clear? That is how we can measure the percentage error in a ammeter. That is a way to measure the percentage error. Clear? Okay. Similarly, we can measure for the voltmeter also. If we want, we can measure for the voltmeter also. Clear? Okay. So this is the instruments we have covered. Our next instrument is basically belong to the potentiometer. First we will understand what is potentiometer. So let me show you the diagram of potentiometer. It is not that much clear, but try to let me draw for you. This is basically a potentiometer. Let me write the few things for you. It is not that much clear. Basically this is a potentiometer. Potentiometer. Okay, I will draw the diagram for you also. I understand it is not clear. You can see here there is a metallic strips are there. There is a one metallic strip here. there is a another metallic strip here. Okay, you can see there is also a metallic strip like this here also, one metallic strip here like this also. Okay, these are what? These are metallic strips. Okay, these are metallic strips of copper, basically of copper. Okay, then you can see there are the free space here, some free space here also, and basically you can see there is a 1 meter scale. Okay, there is a 1 meter scale, means this is a scale. This is a scale whose length is 1 meter, or you can say 100 centimeter. This is the length of this scale, correct? This is how the potentiometer look like, first of all. Then how to use this potentiometer? First you have to understand the basically first you try to understand that what is the diagram of potentiometer. This is the exact diagram of a potentiometer, where we have a two empty spaces here and here. We have a 1 meter scale, then we have a strips, okay, metallic strips of copper, and between this between all these things, we have basically, if these things are clear, then you can see after all these things there is a one more important thing is there within this, that is not visible in the diagram, but let me tell you, there is a lot of thin wires between these two, between this gap. You can see this gap, there is a lot of thin wires are there, lot of thin wires like this, and the length of this thin wire is 10 meter. Means the total length, if you open that wire, it will be a 10-meter long wire. Okay, but how they used to put? They used to put like this. They used to place that 10-meter long wire into like this, where one wire is length is 1 meter. So basically there are 10 turns are there to make a 10-meter long wire like that. So that is how this wire has been wrapped in this space. Clear? So this is a general structure of or how potentiometer look like. Okay, first of all you have to clear this thing. If it is clear, now we will understand the working. Basically now we will understand what is the application of this basically. So there are the two applications, applications of potentiometer. If you see, there are the two applications of potentiometer we have. Okay, one application we will cover in this class, and the another application we will cover in the another class. Okay, yeah, so there are the two applications. The first application is the Wheatstone bridge. Wheatstone bridge means help us to measure the unknown resistance. Means measure the unknown resistance. Basically, if you have seen the diagram, let me draw the diagram for you. Okay, let me draw the diagram for you and try to understand the things properly. Okay, so this is a everyone draw this diagram in their notebook. Okay, okay, so this is what here what we used to keep here we used to keep resistance box, means this resistance we will know. Okay, we know that it is a known resistance. Okay, it is a known resistance. Okay, it is a known resistance. What we will do here, we will connect some unknown resistance. Here we will put some unknown resistance. Okay, here we will put some unknown resistance. Then what we will do, basically we will take a one galvanometer. Okay, and this is a scale where we have a readings are there. Okay, like this. So readings will be there. Suppose the length is, generally the length is 100 centimeter, but you take as a length is L. Okay, the length is L. And then what we used to do, then we used to connect take a one jockey. We used to take a one jockey. Jockey will be something like this. It has a plastic body. Okay, it will be something like this. It has a shape like this. We used to take this jockey. Okay, and what we will do, see, there are a lot of like wires are there. Okay, I told you that there are a lot of wires will be there, and the length of each wire is 100. We used to move this jockey on the wire until we will get a null deflection. What do you mean by null deflection? What we used to do here, we used to connect a one galvanometer also. Here we used to connect a one galvanometer. What we used to do, we used to move this jockey over the wire. Okay, until we get null deflection. What do you mean by null deflection? Null deflection means the current means the current in galvanometer should become zero. Means if you will see on the screen of galvanometer, you will find that it will point to zero like this. Like this it should be happen. That is called as a null deflection. If you are able to get this thing, then we can say if we have got the null deflection, and at null deflection it will become as a Wheatstone bridge. How? Let us see. This is what? This is known resistance R. Okay. Suppose this is a point A, this is point B, this is point. This point is B, so obviously this will be also B. This point is D. Okay. This point is also A, correct? If this is D, this will be also D, correct? And let this it will somewhere, let us suppose it will touch somewhere here, okay? And suppose this length is L1, and suppose this point is E. You can say we have point A, B, D and E, and the resistance of this wire will be given as lambda ohm per meter, correct? Lambda ohm per meter means for 1 meter what is the resistance? That is lambda. So what is between A and B? Between A and B we have a one resistance that is known to us, that is R. What is between B and D? It is an unknown resistance, we don't know, that is as X. What is AE? AE is the length L1. What is the resistance in the L1? That is resistance in the L1 will be defined as L1 lambda. Similarly, what is the resistance in ED? The resistance in the ED will be defined as something called 100 minus L1. Sorry, 100 minus L1 lambda. Okay, the total length I have taken L or 100, whatever you want you can take. So, and there is a galvanometer between this. You can think that it is like a Wheatstone bridge only, and here the current is zero because we have got the null deflection there. So in this case we can write R upon lambda into L1 is equal to X upon 100 minus L1 into lambda. So lambda will cancel out. So from here resistance is equal to 100 minus L1 divided by L1 into R, correct? So this is the how we use the potentiometer to calculate the resistance of a unknown whatever the unknown resistance we have given, we can calculate its value by using this potentiometer arrangement. Now sometime they will ask some type of question like, suppose they have given something like this. Okay, suppose I move this galvanometer this side, okay, or let us do something like this. Okay, suppose I have increased this resistance value, okay, suppose this resistance value increases, so will the null point is going to be move in this direction or in this direction? Think and tell what will happen to the null position, whether it will move in this direction or in this direction. Just try to think. If I increase this resistance box value, or you can say known resistance value, the null deflection E point is going to shift in the left hand side or right hand side. That is what you have to tell. See, one thing is clear, if you are increasing this thing, okay, I can write it as, if I am increasing this thing, this ratio has to be same, correct? If I am increasing this R value, obviously this ratio will increase. Only when this ratio will increase, so this has to be also increased. See, X value is fixed, some unknown resistance is fixed. I have to increase this value, correct? So there are the two methods to do this. Either we can increase L1, because only one variable parameter is there, L1. 100 minus L1 is automatically vary if we vary L1. So I have increased this value, I want to balance it. If I want to balance it, you can logically think कि I have increased this value, and if I want to match it with this condition, I have to decrease my L1. I have to sorry, not decrease, I have to increase my L1, then only it will be balanced now. So that means my E point is going to be shift in this direction. In which direction? In right hand side. So when I am increasing this resistance, my E point is going to be shift right hand side. So in the question they won't mention you that in which direction they are going to shift it. You have to understand by your own logic. And what is the logic? That is the from here you have to think. That is a basic math. So you have to think by your own logic in which direction it is shifting. See, there are the direct formula based questions are coming into the exam. So we are not going to solve example on this in the end of the chapter. We will do some examples, but yeah, this is a simple formula based questions are coming into the examination. Only the typical question they can make is the shifting. If you understand the concept, you can simply tell that in which direction it is going to be shift. Clear? Okay, please note it down. So till here, anyone have a doubt regarding anything? I hope everything is clear till here, and I hope you like this session, you have enjoyed this session. If you have liked it, please share it and subscribe it. Basically, I have seen that lot of you lot of students need the proper notes and everything. So if you want to get the notes, then you have to join our WhatsApp group link. From there, basically there we used to share our all the notes and details. If you want the notes and everything, then you have to join our WhatsApp group link that is given in our channel discrimination. You can go to the channel and check there is a discrimination, and there only you will get our WhatsApp group link. You can join and you can get all these notes and PDF. Clear? Till then, take care, goodbye, and have a nice day. Thank you.